Alright, now let's continue and check question number 2. Now they say the letters A to F in the table below represent 8 organic compounds. We have A up to F. Now let's get the question and then we'll refer to the diagram. Write down the IUPAC name of the compound A. Here's compound A. Now look at compound A, we're going to check the longest chain first. So we can start from let's just give it the benefit of doubt, say 1, 2, 3, 4, 5, 6, 7. Now if you count the other way around, we still have 1, 2, 3, 4, 5, 6, 7. So this will be the longest chain of our structure. So we have 7. So now we know that, okay, we have 7. Now we need to count. Okay, let's have 2, 7. Okay, we have 1, because this is a look at when you look at the structure, it's hierarchy. So say 1, 2, 3, 4, 5, 6, 7. Or another one can say now we can have 1 this side, 1, 2, 3, 4, 5, 6, 7. Then from there we check the number of substituent or the branches, and then we start to count from where there is less. So now let's check the blue ones. If we start from 1, 2, and then 3, we get a branch. So we're going to have 3, and then at 4, 5, 6. At 6 we have 2 branches, so we're going to have plus 6 plus 6, and then now we're done. So this will give us 9, or we can say 12 plus 3, this will give us 15. Now let's calculate the red ones. So the red ones will have 1, 2. At 2 we have branches BRN, the methyl. So we're going to have 2 plus 2, and then now we move on to 3, 4, 5. At 5 we have, can you say, we have 2 branches, which is Cl and the methyl group. So we have plus 5 plus 5, and then now we're done. So this is 10, this gives us 14. So this will give us 14. So in other words, we missed chlorine when counting the blue ones. 1, 2, 3. In fact, there are 3 times 2 there. There is 3 plus 3, so that we have a chlorine and a methane, and then of the other one. So 6 plus 6, so in fact we have 18 here. So that's what we had. Right, so we're going to take the one with the shortest number here is 14. So we're going to take the red ones so we can erase these blue ones. So this happens normally when there is a halo alkanes. So our name then will be, start from the number we have. Let's just assemble them. So we're going to have 2 bromo, then another one we have 2 methyl, which is this one. Then we move on to 3, 4, 5. At 5 we have a chloro, and then at 5 again we also have a methyl. So the name up to 7 is heptane. Now when we need to write this, we must put them in order. So between bromo, B and C, so there is B coming first, so it means we're going to have 2 dash bromo, and then what comes next, then we have a chloro, so we have dash 5 dash chloro. Then what we have methyl on number 2 and another methyl on number 5, so we have 2 comma 5 dash dimethyl. Dimethyl, the last one, we're just going to set it here, heptane. So that will be the correct name for this structure here. Number 2, write down the general formulae of the homologous series to which compound C belongs. What is C? So they say write down the general formulae. So this is an alkene, so we simply have CN, C, not C. So simply have CnH2n. Write down the structural formulae for compound E. Compound E structural formulae here. Let's just insert it here. So let's start by the parent name. This is compound E. Parent name is heptane. So we're going to have 7 carbons. 1, 2, 3, 4, 5, 6, 7. And from there is carbon number 3, where there is ethyl, and on carbon number 3 again there is chloro. So we can choose this to be carbon number 3, and then we can have Cl here where we have chloro, and then we can have 2 carbon atoms here where we have these ones, which is the ethyl. Then now we're going to fill up the hydrogens here. Right, that will be the structure, correct structure for the one. Write down the name of the functional group. Here they are saying functional group, not homologous, to which compound D belongs. So here is compound D. They want the functional group where compound D belongs. So which one is this one? So let's check what's happening. So we have C bonded to 1 hydrogen, and then there is also C bonded to carbon, and then another C coming in, but these carbons must have 4. So we have 1, 2. this one is having 1, 2. So we need to have 1, 2, 3, 4. Then 1, 2, 3, 4. Then this carbon is having 2 hydrogens like this, and the last carbon is having 3 hydrogens. So this is because they write down the name of the functional group. So this is an alkyne. This is an alkyne group. Alkyne group. Or we can write triple bond. Right, draw structural isomer for compound F. Yes, compound F. So the way it is just C having 3 hydrogen atoms. The carbon namilo will have C, and then it's not having hydrogen, so it means it's going to have the oxygen double bond 1, 2, 3, 4, and then it means the oxygen with H here. Now if you look at this one, is a carboxylic acid. Now we need to change this carboxylic acid to an ester. So an ester, it means this O, this oxygen here is going to join these two carbons. So that's why we have the carboxylic acid. So let's write it in blue. So of course we can erase this one here. Right, isomer. So we're going to have, let's write it here. We're going to have C bonded to oxygen bonded to carbon. So if it's an ester, we must have 2 carbons joined by oxygen. That is always the case. And now what is left? One of the carbon must be having the oxygen in double bond. Then of course here there will be hydrogen, and then how many hydrogens were there? There was still 3 hydrogen of this carbon. Now that will be an isomer of this structure. In fact, they're saying structural isomer. So they are supposed to say functional isomer because we don't have a structural isomer here that can be written. So it's supposed to be a functional isomer because there is no way you can rearrange this structure. So it should be here, it should be functional isomer. Write down the name of the homologous series to which compound B belongs. The homologous series to which compound B belongs. What is compound B? B is here. So because of 1 O in the center, so it's going to show telling us that we are having ketones. So that was question 2. I hope we got it correct.